This is NOAA, a place of pioneering science, of discovery, exploration, and innovation. From this building at the foothills of the Rockies, the National Oceanic Atmospheric Administration is directing research that plumbs the depths of our oceans and the farthest reaches of space, seeking knowledge that leads to a better understanding of our precious planet. Hello everyone, and welcome to The Conversation, originating initially today from the Space Weather Prediction Center at NOAA in Boulder. And yes, we are looking at live pictures of the sun. Two different panels, two different views, but in real time. Just one of the many amazing missions underway at this beautiful and remarkable campus in the shadow of the Flatirons up here in Boulder. To begin our broadcast, a brief look at some of the amazing equipment, people, and projects here at NOAA. This is a live video feed of our sun. Two different filters providing two different looks, broadcast from cameras aboard a NASA satellite. Engineers in a NOAA control room in Boulder watch it around the clock. And the sun isn't the only thing they have their eyes on. They also watch the movement of the continents, measure ancient atmospheres trapped in glacial ice, and send weather balloons to the edge of space, where the air is so thin the balloons expand until they burst into shreds. Here it is in slow motion. Scientists here analyze every step of every process. The National Weather Service is here as well, monitoring phenomena closer to home. In Colorado, they want to know where the water is going.
The placement and amount of rainfall is still the thing that we struggle with a lot. From a water standpoint, which river basin is that going to go in? Which burn scar is that going to flood?
NOAA helps with technology that can track virtually every droplet of moisture over the continental U.S., using their high-performance computing capabilities, which also add in observations from high-flying aircraft and wind speed calculations. Billions of bits of data analyzed second to second by some of the fastest supercomputers on Earth, running at such high speeds, generating so much heat, they have their own water cooling systems.
You can notice even your computer, your laptop can get hot when you're using it. And so this is like 10,000 laptops all in one room, so we've got to figure out how to keep it cool.
And on the matter of high temperatures, the massive wildfires that have been sweeping the West have NOAA examining another potential threat: toxic smoke.
We want to find out how much actually smoke comes out of fires, how much are the emissions, where do they go, what's in the smoke, what's harmful in the smoke, and how is it affecting people that are living downwind in the smoke.
In all, 698 offices, some 800 people, and 98 high-tech labs, all dedicated to helping us better understand our world. And among those 800 people, one of the best and the brightest, Robert Steinberg, who is the acting lead for the Space Weather Prediction Center, which I have to tell you is one of the most remarkable pieces of science I've ever seen. Really incredible to walk up here and realize we're looking at the sun. I would imagine that's everybody's first reaction. How did they do that without going blind? Your mother always told you, don't stare at the sun, yet you've been doing it for a long time now.
Yeah, it's especially fun if I'm working a night shift and I tell people I'm going to work to look at the sun.
We have two different views
have
here.
A really large commute.
Well, yes, absolutely. Two different views here, so tell me what we're looking at. First, the view on the left.
Okay, so on the far left you can see 6 images of the sun. That's the sun in various wavelengths, and it's similar, you can think of it similar to if you go to the doctor and you might get an x-ray or a CAT scan or an MRI, and that helps the doctor with his diagnosis. In this case, we're looking at different wavelengths of sun's radiation that allow us to diagnose different features on the sun that may have an impact here on Earth.
And then the sun itself, that we have this two shot of one sun on the left and one sun on the right. Sun on the left is the sun.
That's correct. They're actually both the sun. Again, we're looking at different parts of the sun. So the corona and the chromosphere. So the different wavelengths also allow us to see different depths into the sun's atmosphere. And again, different physical processes occur through those different layers, and so being able to monitor all of that is a substantial benefit for us as forecasters.
And then on the right, it looks as though some filtered version of the same picture.
That's correct. So now what we're looking at, those two images, the red and the gray one, are from an instrument aboard a spacecraft called SOHO, and the instrument is called a coronagraph, and the coronagraph creates an artificial eclipse of the sun so that we can see the outer atmosphere of the sun, or the sun's corona. And what we're looking for specifically in those images is something called a coronal mass ejection, which is a large eruption of plasma that actually leaves the sun's atmosphere and goes out into interplanetary space. If it's directed towards Earth, then we have to monitor it because those can produce geomagnetic storms.
And right now we're in a quiet period for the sun, is that right?
That's correct. We're entering what's called solar minimum. So the solar cycle is on average 11 years long. And so we just hit a peak around 2014, and we've been in the declining phase. So we're kind of bottoming out now. And during that time, we can still have activity in sunspots and things. In fact, a few weeks ago, we had a solar flare, small one, and an eruption. But the frequency becomes a lot less. During solar maximum, you see a lot more activity.
And in fact, there's a lot of people looking for information about solar flares. They can have a significant impact.
That's correct.
Yep.
That's correct. So there's a variety of impacts, beginning with the solar flare. It gets here, the energy gets here in 8 minutes, traveling at the speed of light.
Gee.
It can energize our ionosphere, upper layer of the atmosphere that reflects radio waves, and that can produce problems for people who communicate using high frequency radio. So that's an immediate effect. After the flare, you can also have what I mentioned earlier, a coronal mass ejection, that eruption of plasma into interplanetary space. I liken it to interplanetary projectile vomit from the sun. And it can get here in as little as 17 hours to as much as 3 days.
Amazing.
And the important thing about those is they carry a magnetic field in that plasma cloud that, when it interacts with Earth's magnetic field, can cause geomagnetic storming. And that in turn can cause issues for power lines and things like that.
I see.
And pigeons get lost during that as well.
Absolutely. And this is a control room that is monitored 24/7. You guys are here all. People should rest at ease knowing that you're here all the time.
That's correct. It's part of the National Weather Service. So just like a regular National Weather Service forecast office, like our colleagues upstairs in the Denver Boulder office, we're staffed 24 hours, except our warning area encompasses the planet, and we're focused on the sun. But yeah, there's 2 people on duty typically around the clock, and they monitor the conditions on the sun, and they issue watches, warnings, and alerts when the conditions warrant, and those go to a variety of customers, ranging from aviation to the power industry to satellite operators. There's a whole swath of people, and as technology grows, the customer base continues to grow.
Right. Well, it's a remarkable place, and I want everyone to know that actually Robert's on the tour, a fabulous tour. It's now the E-Ticket Tour, the A-List Tour here in Boulder. If you've done the Celestial Seasonings Tea Factory, this is the one you haven't seen, and you get an opportunity to see the sun as we are now, up close and personal, and we'll tell you more about the tour coming up later in the program. We're going to run upstairs and see your friend Greg Hansen at the National Weather Service, since we know you guys work hand in glove. But it's my pleasure to meet you, and thank you for being vigilant and for your wonderful expertise on what's going on in deep space.
It was my pleasure. Thank you for coming out.
Robert. Okay, thank you. Just above the Space Weather Prediction Center is the Office of the National Weather Service, and Greg Hansen, who is the warning coordination meteorologist for the Weather Service. And in fact, you're in the same office as many of these people with NOAA. You guys work hand in glove. But you are a guy who's particularly happy when the sun is shining everywhere, rather than having to follow a lot of nasty weather.
Yeah, it makes our job easier when it's quiet weather, but we're enthusiasts too. We love the weather, so we like it when it mixes things up a little too.
Right, and I know the bombogenesis was something that did that in Colorado this winter. So much discussion about that. I've been here for a long time, I've told you, and I've been in a lot of bad storms. But in, say, the last 40 years or so, if you've lived in Colorado, have you experienced a bombogenesis, or is that the first one?
Yeah, it's possible. The pressure drop that defines what a bombogenesis isn't one of those parameters, weather parameters that we track very closely to go back and look and see. This one just bubbled up during this event, and of course like the polar vortex, that kind of terminology just takes on a life of its own.
It's quite the storm. So it's a really nice day in Colorado today. There's some gusty winds.
Gusty winds and a little some showers on the eastern plains. And
you're watching the snow. I know the snow melt is something that you're watching very closely right now. And actually we've had a spring a little chillier than normal, and you say that's a good thing.
Right, it delays the snowpack a little bit. We do have a well above normal snowpack out there now. So now it's a matter of just how it melts out, how quickly the warm temperatures come to ripen the snowpack to get it ready to release its meltwater, and also any rainfall on top of that. It's the snowpack itself isn't a problem. We just need to wait and see how it comes out.
Are we going to have, do you think, Greg, an exceptional fire season? Does all the water help us, or are we just growing more fuels for fire?
A little bit of both. Up in the mountains where we do have the deep snowpack, that's very good for those larger fuels, the big trees that are down and that sort of thing. That really soaks in and makes that threat smaller. Further east, though, with the moisture we've had, that will grow a lot of vegetation through the spring, and then we could, depending on how that dries out in the summer, that could be a little bit more of those fine fuels, the small fuels available for fire. So it's kind of a wait and see type thing. We never drop our guard on that.
We're going to have a big conversation about fire with two of your colleagues in a minute, and especially a big NOAA study coming up on smoke. But let me ask you, in terms of the wet winter that we had, all the snow, and what has generally been a pretty damp spring as well, is that El Nino this year? Or, I mean, there was La Nina and El Nino used to be the big discussion for weather.
Right, and we've seen two good examples of that the past two winters that we've had. This year has been an El Nino winter. We've been a little late getting it started, but the storm tracks for El Nino tend to take more of a southern track, more moisture with them. They tend to hit southern Colorado with more snow than the north, but it's usually good for the whole state. And that's what we've seen this year. Maybe on the high end, a little more snow out of this than what we were expecting, but we're looking for more snow than we normally get. Last year, the La Nina was more of a northwestern storm track, and so it tends to be a little drier. They can only bring the moisture with them from the northwest, and we saw that last year. We had below normal precipitation all winter.
I would think, as the warning coordination guy, spring would be your Super Bowl. I know nothing about the weather, but I just know springs can be really bumpy here.
Right, yeah. We're gearing up for our summer convective season and springtime, so we've already issued our first severe thunderstorm warning, and we've had that tornado up in Weld County as well, so we're off to a start.
Everybody wants meteorologists to foretell the future. So what do you see for this summer? Is it going to be hot and dry and lots of fires, or is it going to be damp and quiet? I mean, do you have a guess, if you could make a guess?
Yeah, the outlooks call for continued better chances for wet through the spring and early summer. So we'll be looking for that. That could be in the form of those severe thunderstorms, so that's something we'll need to watch out for.
Having just seen a lot of pictures of the sun, it really worries me how hot and intense and close it is. And sun is still a huge player. Colorado has so many sunny days, still a huge player in our weather.
Right, yeah, it's one of the things that makes it great to live here too.
Yeah, no question about it. Well, we're going to talk all about fire, and a lot of people in Colorado, a lot of people in the West worried about fires and wildfires, and we're learning about some changing characteristics of smoke. And in fact, I know that you were involved in some fire forecast and how fires make weather. So we're going to be joined by two of your colleagues, and we're going to look at a very exciting NOAA project that's coming up with Greg and two of his colleagues about a study this summer to tell us about how smoke changes as it moves across the continent from one state to the next. So Greg Hansen, the shortest meteorologist on the planet, now joined by two of his colleagues, Carson Warnicke, who is a NOAA research scientist, also with CU, and Joshua Schwartz, also a NOAA research scientist who is looking into aerosols. And we're talking about fires. Greg, what we've learned is that a lot of fires actually do, in fact, generate their own weather.
Right, the really intense fires with a lot of heat can create fire whirls, fire tornadoes, if you will. They can affect the wind that's blowing into the fires as well.
We know it was a tough summer last summer for a lot of people, Joshua, and what we know is that most all characteristics of smoke are bad. There is really no good smoke.
I've never heard of any that's good. And the more you can keep away from, the better for you.
And what we learned about human beings generally, Carson, is that the human nose is repulsed by by two smells, or dislikes two smells in particular, which are?
Which is fire, because it's dangerous for people, so you have to stay away, and rotten meat, because you should not eat that anymore. So you're very good at smelling fires.
And that's why it was a miserable summer for so many people, because the smoke was so bad. So what's happening now is there's going to be a huge project, a joint project between NOAA and NASA and many other entities this summer to study smoke. And we're looking at the composition of smoke and how it changes as it moves across the country.
That's right, and how it's transported. So when smoke is emitted from the fire, you can imagine it's very hot. As it rises in the air, it can cool, and so that can change the amount of material that might be in an aerosol or particle phase and the amount that's in gas, and then chemical reactions can occur as it's transported.
And some of the worst fires this summer, we're learning, because we've been fortunate in that we've had a lot of moisture, Karsten, but some of the worst fires will be in the Northeast.
Very likely will be in the Northeast, because there was less moisture this year than last year. And last year, Idaho was an area where it was really dry. And that's why we had these really intense fires in this Idaho region in the northwest of the U.S.
Right.
And this year will probably be the same, but somewhat more further west in Washington.
So you would think, Greg, that the good news might be that, gee, well, those fires aren't as close to us as maybe they were last summer, so maybe we'll escape all the smoke, but perhaps not.
Yeah, we can still see that smoke from that far west still transport into Colorado.
The project with NOAA and NASA, we were in your lab, which we saw earlier in our broadcast, and you were working on an instrument that in fact can see particulate, I think, down to 1 trillion of a part per billion, 1 trillion of a part per million?
1 part per trillion. So that's about as much as one drop in a swimming pool.
Remarkable, yeah.
So we can detect all these compounds, thousands of compounds in the smoke, and understand what the fire emissions are in great detail with these instrumentations that we have.
So the idea is to this summer learn a lot more about smoke, what's in it, how it travels, and most particularly how it impacts human beings.
Yeah. So this will be the study where we investigate fires in more detail than ever before.
And this instrument that you guys have designed, it flies on the outside of the aircraft. You drag it around behind you. You're going to be airborne, obviously.
That's right. And actually, most of the instrumentation is inside the plane, where it's a little bit better controlled in terms of temperature and pressure. We can keep things running nicely. And then we suck air in from outside of the airplane.
I see.
There are probes on the wings of the plane for looking at very large particles that are hard to get into the aircraft. But Karsten's instrument, which is focused on gases, it doesn't really suffer from being inside as long as you suck the air in quickly. Is that right?
We basically just stick a tube out the window and suck the air into our instruments and can analyze them there in great detail.
How about that? Yeah. Who would think science could come down to something as simple as that? But are we going to have a worse fire season, do you think, generally? I read that if you live in the western United States, you just are going to have to live with the reality that you're going to experience fire. So for Westerners this year, a better year or a worse year? What do you think, Greg?
I think the areas where we're seeing that deep snowpack this year already are in better shape than we have been in previous years. And we had the drought last year and a pretty active wildfire season here in Colorado. A lot of snowpack, gonna put a lot of water into those big fuels. Here along the Front Range though, where we haven't kept snow all season long, we could grow a lot of fine fuels and then that might be available to burn, but we still need to see the way the rain for the rest of the summer plays out.
I think I read that those fuels can dry out in as little as 3 days in the heat, and then they're ready to burn, no matter how wet they were to begin with. Well, you guys won't be preventing fires, but at least we'll be learning more about them and the nature of them and living with them, I guess, which is just going to be part of our reality. Well, we'd love to follow the project. Good luck to you this summer, and it'll be interesting to see what you learn. Is this one of those things where you'll learn a lot instantly, or it's going to be years down the road before we know what you found out?
It will be years down the road till we know everything that we need to know about fires.
Yeah, so my nose will still be very offended by smoke and rotting meat, no matter how it turns out, right?
Yes.
Well, great good luck to you with the project. I know that in the campfire in California this summer, those fires were moving approximately at 8 football fields a minute, so let's hope we don't see any more of those kinds of fires.
Right, it takes very strong environmental winds to move that and to get those big embers to kind of jump ahead of the flame lengths to spread that fire that much more quickly.
I know that NOAA and NASA and the Home Builders Association are all working on solutions, trying to come up particularly with a home that doesn't burn. And I know that all of you are indirectly associated with that with the work that you do. So great good luck to you, all of you this summer. And hopefully we don't hear a lot, although we'd love to hear from you, Greg. Maybe not as often from the warning coordination meteorologist. Thank you all for your time today. I deeply appreciate it. And thanks to all of you for joining the conversation. Let's talk again soon. Tours of NOAA are every Tuesday at 1 p.m. To register, go to www.esrl.noaa.gov and book early because the tours fill up quickly.